Welcome back, geometry students. Mrs. Fallon here. We are on section 10.5 in your student journals. I'm on page 300 if you want to join me. Okay, so in this section we are talking a lot about some different properties given some scenarios with angles and arcs and lines that are tangent and all kinds of fun things. So one of the words that we're going to talk about today is something called a circumscribed angle. And so a circumscribed angle is, remember, circumscribed, it means kind of like within a circle. So a circumscribed angle, imagine you have a circle, and then imagine you have an angle like on the outside where the two line segments, like this segment here that makes up this angle and this line segment here that makes up this angle, have to be tangent to my circle. So if that's the case, then this angle in here is called a circumscribed angle. Talk a lot more about that when we get into the properties and we start using that theorem. There's going to be a theorem that kind of deals with that, but that's kind of the main vocab word for this unit. Okay, so let's talk through a couple of these theorems, and I think it would just be easy if I kind of gave you a couple examples, and so hopefully that makes a little bit more sense. So in this first one, tangent and intersected chord theorem. If a tangent and a chord intersect at a point on a circle, then the measure of each angle formed is 1/2 the measure of its intercepted arc. So basically what we're getting at here is like to figure out angle 1, it's half of this intercepted arc, right? So that would be angle 1 is half of the measure of arc AB. Likewise, angle 2 is half of the arc of this major arc here. So it'd be arc BCA. And again, the difference between a major arc and a minor arc, remember, a minor arc is less than 180 degrees, whereas a major arc is greater than 180 degrees. So a scenario that you might see, like an example, right? So let's say we had, a circle, and let's say we have a line tangent, and then we kind of have this angle in here. So it kind of looks like that. Let's say this is 40 degrees. We'll call this A. And we'll call this arc here B, and then we'll call this major arc here 280 degrees. So I have a minor arc B, I have a major arc 280 degrees, and I have two angles. So what I'm getting at here is like the relationship between both of these. So angle A, for example, is going to equal half the measure of its intercepted arc. So like half of 280 degrees would be 140 degrees. And so that's how you'd figure out angle A. Now, if you were going the opposite direction, you would say this angle, which is 40 degrees, is equal to half of this intercepted arc. So this angle has to be half of arc B. So you can solve it algebraically, or you can think about it more common sense. So if 40 degrees has to be half of arc B, then obviously B has to be 80 degrees. Or you can solve it algebraically by just saying 40 equals 1/2 of B, and then multiply both sides by 2, and you would get arc B there. That B represents that arc, that minor arc would be 80 degrees. So that's what that theorem is stating. All right, so then we have some quick vocab. If we're talking about intersecting lines that intersect on a circle, just means the point of intersection is on the circle. This is inside the circle where the point of intersection is inside the circle, and of course, outside the circle. So there's a theorem here, angles inside a circle theorem. So it says if two chords intersect inside of a circle, so that's kind of like this scenario up here, then the measure of each angle is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. Okay, so there's a lot of words there, but basically here's what we're getting at. To get the measure of angle 1 here, if we take half, if we add up these two intercepted arcs, so arc DC and arc AB, and then we take half of it. So like angle 1 would equal 1/2 the measure of arc DC plus AB. Likewise, angle 2 would equal half the measure of arc BC plus AD. Let me show you an example. So let's say we have a circle, and then let's say we have some inside, so the two lines that intersect inside our circle. I'm going to give you some measurements here. Okay, so if I wanted to figure out, say, the measure of angle 1, I would say the measure of angle 1 is equal, so this angle is equal to the 1/2 the sum of these two arcs. So you do 1/2 of 20 plus 60. And so in this case, obviously, you would get 20 plus 60 is 80, so 1/2 of 80 is 40 degrees. So the measure of angle 1 would be 40 degrees. Likewise, the measure of angle 2 would equal half the sum of 120 and 160. So this would be half of 280, which is 140 degrees. So that's kind of the second theorem in this section. There's a couple more that we're going to talk about, and they're on the next page. And then we're going to kind of put it all together and do some practice where we can kind of look at it all together. All right, so let's go to page 301. This theorem deals with angles outside of the circle. So two lines that intersect outside the circle. So notice the point of intersection is out here. So kind of like the ones that were inside, very similar, but instead of having it be the sum, it's the difference. So if a tangent and a secant, or two tangents, or two secants, intersect outside of a circle, then the measure of the angle formed is 1/2 the difference of the measure of the intercepted arcs. So again, to get this measure right here of angle 1, you would take this arc and this arc, subtract them, and take half. And so regardless of your scenario, if you have tangent and a secant, two tangent, two secant, doesn't really matter. You're taking half of the difference between those two arcs. So again, let me give you kind of an example. So here's a circle. Let's do two tangent lines, not that it matters, but let's do two tangents. We'll call this angle 1, we'll call this 120, and we'll call this major arc 240. So if I was to figure out the measure of angle 1, I would take the major arc here, so this big arc here, so 1/2 of 240 minus this other arc. So 240 minus 120 is 120, and 1/2 of 120 would be 60 degrees. So in this scenario, my angle 1 would add up, or would equal 60 degrees. So again, to get this outside angle, you take this arc, subtract that arc, and then take half of it. All right, so here comes that circumscribed angle. So remember, a circumscribed angle has to have two lines that are tangent. So this is tangent, and we're referring to this angle here. All right, so there's a theorem about it. So it says the measure of a circumscribed angle is equal to 180 minus the measure of the central angle that intercepted the same arc. Okay, that one's a little confusing as well. So let's draw a diagram. So if we have a circumscribed angle, okay, so let's say angle 1 here is circumscribed because it's tangent to my circle. What we're getting at here is that, let's say, if we have a central angle, so let's say here, these are the lines, so this is where it's tangent to my circle, these 2 points. And this is the center of my circle. So if I draw a central angle, okay, what I know is that this measurement here, we'll just call this 150 degrees. To figure out angle 1, so the measure of angle 1 would equal 180 degrees minus the measure of that central angle. So since the central angle is equal to the measure of its intercepted arc, this angle here would equal 150. We would take, to get this angle here, we would take 180 and then subtract off whatever this central angle is. So in this case, in my diagram, my angle 1, that circumscribed angle, would equal 30 degrees. All right, so there's 4 theorems here that we're talking about, I believe, and gets a little bit confusing. So let's kind of put this all together. I'm on page 302. This is just kind of the extra practice that I would like to kind of work through with you guys together. Just kind of show all the different theorems in action. So first one asks for, it says line CD is tangent to the circle, find the indicated measure. So angle ABC. So if we're looking for angle ABC, that's this angle here. Well, we already know this is 70 degrees. We know that these two lines, so this line is tangent, we know that has to form 180 degrees, which means this angle here has to be 110 because we know they're supplementary, and 180 minus 70 is 110. All right, so now we're asked to find the arc AB. So this is one of the first theorems we talked about. So that arc is basically twice as big as this angle here. Or you can think of it as this angle is half the arc, however you want to look at it. So if 70 degrees is half of the arc, that means the arc has to be twice as big, which in this case would be 140 degrees. Arc AEB, so AEB is right here. Well, that's just the rest of the circle. So if we know this piece is 140, we can take 360, subtract 140, and get 220 degrees for this arc. Now, there's another way of doing that one, right? So we could also look at this angle here and say, well, this angle has to be half of this arc. So obviously this has to be double it. So double 110 would be 220. All right, let's look at some more. So on this one, we're asked to find the measure of arc AB. So there were some pieces of information that they gave us. So arc ADB, so this whole arc here, ADB, equals 220 degrees. Angle B is 21 degrees, and I think that's it. All right, so I guess what I would start with, they're telling us this information for a reason, right? So if you look, this is that first theorem. Here's my angle, and this angle here, angle A, has to be half of this intercepted arc. So I know that the angle A has to be 110 degrees. So I'm looking for arc AB, actually. So let's kind of go back to this. So arc AB. Well, there's a couple ways you could do this. If you notice that all of this is 220, you could just take 360 and subtract 220, right? So 360 minus the 220, and you would get 140 degrees. And that would be the rest of this arc here. You could have also figured out that this angle here was 70 degrees, and therefore this arc be twice as big. So you could have done it that way too. All right, angle ACB. So if we know this is 110 and we know this is 21, well, all three angles of a triangle add up to 180. So let's subtract 110 and let's subtract 21. And so angle ACB would be 49 degrees. All right, so let's use some of the other theorems that we talked about. All right, so in this one, this is where the two lines intersect inside the circle. This angle here is equal to half the sum of the two intercepted arcs. So it would look like that. So 1/2 of 50 plus 92. So this is going to give me 1/2 of 142, which is going to give me 71. So since it just asked for x, we're good to go there. Number 7, I did a little bit differently. So number 7, they gave us this arc and this arc, which means I could figure out this angle here, but they didn't kind of tell us anything about this angle. So my first strategy is to figure out what A is. And so I'm going to use the same kind of concept that we did over here. So I know that that angle in the middle has to be half of the sum of my two arcs. And since 197, so this would be half of, that's 132. So A is going to equal 66. Okay, so why that's important? Well, we should also know that this forms a linear pair, which means 5x plus 14, okay, has to equal, so we know that this has to equal, 114, because these two angles have to be supplementary. They have to add up to 180 because they form a linear pair. So I just did 180 and I subtracted 66 and I got 114. And so that's how I figured out that this angle here, this 5x plus 14, has to equal 114. So now if we solve for x, I get x to equal 20. So I just subtracted 14 and divided by 5. All right, let's take a look at number 8. So this is the two angles that are two lines that intersect outside of an angle. So this is where you take this arc, subtract this arc, and take half of it. So this angle here is going to equal 1/2 of x minus 72. Let's go ahead and solve this equation. So what I would do first is rather than distribute, I would go ahead and multiply both sides by 2. There we gets rid of that fraction. And now if I just add 72 to both sides, I get 148 equals x. So what that means is this arc here is 148. Same deal, this one, again, this angle here, so that's 28 degrees, is equal to 1/2 this arc here, which is 4x plus 8, minus this arc. So be careful here that you have all this in parentheses. So you are subtracting this other arc. So you do need to put that in parentheses because you have to distribute that negative. So I'm going to go ahead and get rid of this 1/2 by multiplying both sides by 2. So that's 56, sorry. And then I'm going to kind of distribute this negative. So I have 4x plus 8, and I'm going to go minus 3x minus 2. So let's clean that up a little bit. So 4x minus 3x is x, and 8 minus 2 is 6. So if I subtract 6, I get x to equal 50. So a little bit more challenging on that one, but nonetheless, still kind of using those same theorems. So what I would do here is I would practice this on big ideas. Come to class with any questions. All right, that's it for now.